All right, so today we are going to be working on writing the quadratic equation in vertex form. So, what is the vertex for these two different forms here? So if you remember, that first one there is in standard form where we have y equals ax squared plus bx plus c. And remember, to find your vertex here, what do? We take opposite of b all over 2a. And in the equation that we have right here, our a value here is what's in front of x squared, which is 1. What's in front of x, which is negative 1. And then your constant term there of negative 12. So now you can plug those right into your formula there. So opposite of b there, so opposite of negative 1 is 1. And then down here, 2 times a. So that gives us a half, or if you want it as a decimal, it'd be 0.5. So your vertex is going to be 0.5 something. So to be able to get your y value, you want to plug your x value back into the equation up there. So you get y equals 0.5 squared minus 0.5 minus 12. And then you can simply either do that in your head or go ahead and put it right on your calculator there to be able to figure out what that value is. So I end up getting negative 12.25. So my vertex there is a half and then negative 12.25. Or if you're a fraction person, you would say 1/2 and negative 49/4. So then number 2 here, if you remember, is in vertex form. So vertex form is a little bit different here. So we have y equals a times x minus h squared plus k, where your vertex equals hk. So I personally always like to think, instead of looking at hk there, I like to look underneath the parenthesis there and think about, how do I get 0 there? I'd get 0 in there when x there is 4. And then I just write down what's here on the outside, which is a 2. So however you want to look at that, vertex there, hk, which in this case is 4, 2. All right, so now, again, the reminder there at the top there, your standard form is x squared plus bx plus c, and your vertex form there is a times x minus h squared plus k. So we can go ahead, and if we can write the standard form into vertex form, we would then have it in vertex form and have done what we need to do. So we want to change this from standard form into vertex form. And we can do that by using complete in the square. So complete in the square here, if you remember how to do this, I'm going to keep, you're not working on both sides of the equation this time, unlike before. So you're going to move your constant term over here to the right a little bit just to kind of move it out of the way so it doesn't confuse you. But if you remember, what we did before is we took b divided by 2 and squared and added to both sides of the equation. This time we're going to add b divided by 2 squared in there where we want it to be in here. And then we're going to subtract it over here by that constant term. So it's not it's both on the same side there. Because when you add something and you subtract it on the same side of the equal sign, you're going to end up getting back to the same value of x squared plus 6x minus 8, which is what we want. All right, so I'm going to identify my values in here. In front of x squared is a, b is in front of x, and then c is our constant. So our b term there is 6. So again, what I said there is we're going to take b divided by 2 and add it right here. So I'm going to add 6 divided by 2 squared. And then over here, I'm going to subtract 6 divided by 2 squared. And as soon as we clean this up, it'll start to make more sense to you why we're doing that. So if I get y equals x squared plus 6x, what is 6 divided by 2 squared? Well, 6 divided by 2 is 3. If I square it, I get 9. And then over here, I have minus 8 minus 9. Now, if you kind of look at that equation, notice you got a plus 9 and a minus 9 there. They're going to cancel each other out, and you get back to the same equation that we started there with. So we haven't changed the value of our equation by doing this. All right, so now what we want to do here is we want to factor this equation over here. So let's do that. So factoring this, x times x there is x squared. What times what multiplies to give you that 9 and adds to give you the 6. So multiplies and adds. So just like normally factoring. So multiplies to give you a 9 and adds to give you a 6 would be 3 and 3. And then over here I can combine my like terms and I get a minus 17. So now what happens here? You've got 2 of those x plus 3, so I can write that as x plus 3 squared minus 17. So there it is in vertex form. We've changed it from standard form into vertex form, and we have it. So we're good. This one here, same thing. We can change it from standard form into vertex form. So vertex form, we need this to be in, so I'm going to rewrite this. I'm going to write my ax squared plus bx, and then I'm going to put my constant term over here. All right, so again, I'm going to go ahead and do b divided by 2 squared. So my b value this time is negative 5. So I'm going to take negative 5 divided by 2 and square it and add it here. And then over here, I'm going to subtract negative 5 divided by 2 squared. So we added negative 5 divided by 2 squared, and we subtracted negative 5 divided by 2 squared. So I've not changed the value of that equation there. It still can get back to x squared minus 5x plus 2. All right, so now let's clean that up. So negative 5 squared there is 25, and 2 squared there is 4. Over here, I can do the same thing. So I'm going to keep focusing on this section right here. I'm going to factor that. Let me change that back to y. All right. So factor in this. What times what gives you x squared? X and x. What multiplies to give you 25 fourths and adds to give you a negative 5 in there? That would be a minus. It has to be a minus and a minus. This is going to be a minus 5 halves and a minus 5 halves. You take a negative 5 halves and a negative 5 halves and you multiply those together, you get 25 fourths. If you add 5 halves there is 2.5, so a negative 2.5 plus a negative 2.5 is going to give you that middle term of negative 5. You can also tell what to put in here. These two spots here is exactly the same thing as what you squared up there. Before you squared it, that's exactly what goes in there. You see how you got a negative 5 halves and then squared? You put a minus 5 halves and a minus 5 halves. All right, so now we have to clean up over here on the right-hand side over here. So you can either get a common denominator over here. So common denominator over here is going to be 4. So really I have 8 fourths minus 25 fourths. So cleaning that up. And I'm also going to take this now and write it as one term. You got x minus 5 halves squared. And then since the numerator is since the denominator is the same, I can take 8 minus 25 there is 17 and write down the common denominator of 4. Or those of you who like to do this, you might put this in the calculator and go 2 minus 25 fourths and then hit that math frac button if you got the TI-84s or 83s there, and it'll tell you there that it's negative 17 fourths. So there it is in vertex form. All right. So now we've got a little different one here. This one here, notice you got a 2 in front. That's not very good. So we're going to pull it out in front so we can work with it first. So I'm going to pull that 2 out because we need to have 1x squared there in front. So you got to, whatever is front of here, you're going to pull this out in front and just pull out of each of the terms there. So if I take a 2 out of here, I'm left with x squared. If I take 2 out of there, I'm left with a minus 2x. If I take a 2 out of there, I'm left with a minus 5. So basically what I'm going to end up doing here is I'm going to work with this in here. So let's do that. So y equals 2 times x squared minus 2x, and then I've got this minus 5 all the way over here. So let's go ahead and let's complete the square on this. So if we do that, um, we could do that very easily. So working through this, I need to complete the square in here. So my b term here is this negative 2 there. So I've got to take my b divided by 2 and square it. So my b there is negative 2 divided by 2, square that. We end up getting, oh, we'll get 1, but let's put it in here. So let's say plus negative 2 divided by 2 squared. And then I'm going to come over here and do the same thing. Minus a negative 2 divided by 2 squared. I'll put that around there. All right, so cleaning this up in here, we end up getting x squared minus 2x. Negative 2 divided by 2 there is negative 1, squared is 1. And then over here I've got a minus 5 minus 1. So again, haven't changed the value. So 2, and I'm going to go ahead and factor this in here. This right here. X times x gives me x squared. What multiplies to give me a positive 1 and adds to give me a negative 2? It'd be a minus 1 and a minus 1. And then I can clean this up over here, and I get a minus 6. All right, so keep going here. We now have y equals 2, and we've got this x minus 1 squared, and we got this minus 6. So that's not how our equation is supposed to look yet, so we're going to kind of clean this up here. I'm going to go ahead and leave the 2 out here, and I got to multiply the 2 times this term, and I got to take the 2 times this term. So all I kind of did was distribute the 2 through to both of those terms, because I'm trying to make it in the correct form here, and then this becomes a 12. So now it's in that form of y equals a times x minus h squared plus k.